Welcome to this live broadcast for the NPTEL online certification course on bioreactors. This is Ashwati, who has been answering your questions, and I'm GK Suraishkumar. We'll be happy to answer your questions. Let us see whether we have any that are coming up. Questions in the Verma and then Verma. Say something. No, say something is for. Seven. Okay, there are 7 people waiting. Yeah, we are ready to take your questions. There are some which have been asked already, so let us see whether a couple of questions, in fact. Before we get on to the questions, I thought I should clarify a couple of aspects which may have gone through your minds, which comes across once in a while, but it seems important enough, so I thought I'd clarify. One is some students feel, why so much math or why so much mathematics? That typically comes from people who are a little uncomfortable with the mathematics background, or rather they have a limited mathematics background. It so happens that mathematics is the language of science and engineering. That's a well accepted truth if you want to look at it that way. A lot of important manipulations can happen, a lot of important insights can be drawn if you can transfer the information onto a mathematical plane, do it there, and then start interpreting it. That's the reason why we get onto a mathematical plane. Also, the mathematical plane is a lot more complete. I'm not very sure whether you'll be able to understand this, but I'll tell you the reason why we insist on putting things on a mathematical basis. It's a lot more complete. It's a lot more rigorous, a lot more complete, and we'd like to have inputs that are complete for us to be able to manipulate bioreactors effectively in the context of the course. In the larger context of science and engineering, anything for that matter, we'd like it to be reasonably complete. If not complete, at least we'd like to know what the limitations are. That's the reason why we insist on mathematics. This time somehow nobody asked the question. This question comes at least once or twice every time the course was run. Used to come once or twice every time the course was run the last 3 years. I thought I'd clarify that. The second aspect, which I think came just a couple of days ago and even yesterday, was the assignments are too difficult. And sure, it may appear difficult to some students, which means you'll have to work harder to get it done. This is training to get you to learn at a much deeper level, which some of you would be doing pretty much for the first time, depending on the kind of background that you have and so on. So don't be bothered by that, just be with it. I'm sure if you put in the required effort, you would definitely come up to speed and you'll be able to solve problems. As was mentioned in the lecture itself, problem solving is a skill. It needs to be developed. It can be developed. Some students have a natural skill in problem solving. That's fine. They find it easier. For most people, it is a developed skill, and it can be developed. And some tips were given for development of those skills in the videos themselves. Ashwati, would you like to say something in that context? I think you handled him very well in terms of classifying the person who asked the question.
Yeah, I was worried that the UG students are unable to answer the questions.
No, I think he was generalizing. I think he said we are UG students. I think he was representing only himself because nobody else is asked.
But I feel that even as a UG student or whichever level of education you are, if you put in some more effort, you can always improve on yourself.
Yeah.
So I think that is what you must aim for, and that would only make your future bright. And that is what is required.
Very good. Okay, then let's take the question here. Are there any questions as yet? No, I don't think so. Here. Yes. Khyati, yes, even I feel I'm not sure about taking this exam because of the mathematical problems. But let me clarify the way we put together any assignment or any examination question paper. There is an average student level that we know that we can guess at, and with experience, the guess is very close to reality. Um, there are about 30% of the questions that can pretty much be answered by all students. As long as you've done the course, you understand some essential aspects, in this case of bioreactors, you'll be able to answer those questions. Then about 30 to 80% of the marks are set aside for questions with varying degrees of difficulty, um, so that students with orientations towards the subject, who have worked hard, who have put in the extra effort to learn things in depth and so on and so forth, can get in that range, 30 to 80. And the last 80 to 100 is usually set aside for the ones who are really bright, who are natural in the area and so on and so forth. That since we are used to a grading system, the top marks are given to the top grade, and this is the way we set it up. So I don't think you should be worried about taking this exam. Yes, there would be some mathematical part, which I'm sure you can handle. They will be on the lines as lines of the questions in the assignments. They'll be exactly on those. Of course, they won't be the same questions. But they may be based on them, and they will be on the same lines as the questions in the assignment. So if you prepare, if you have understood the course, try always to understand the course. If you have understood the course, if you have understood the solutions to the assignments and so on, you must be able to do reasonably well in the exam. And but this is the way the question paper is designed. So uh, if you do very well either with a natural orientation or with a good amount of hard work, then you certainly get it done, and then everything goes in between. Um, Related to that, can the questions asked in the assignment be answered? I think it will help the students very much. Yes, we will answer them. The answers, the correct choices, I think I mentioned in the assignment solutions when they are released. The tips, I think, are given. Are the tips given? No, tips are not given. So if you need detailed solutions to any assignment questions, please send Shruti note on the forum itself. I think that way it will be helpful to all. Please ask for detailed solutions to the assignments that have closed. We'll be able to do them only for the assignments that have closed. And definitely Ashwati has these solutions. You have all the solutions. So she can share them with you. That's not a problem. And there are other questions. Oh, Kathy says, yes, sir, thank you. You're very welcome, Kathy. Hope to see you in the exam. The registration date is still open for the exam. Yeah, please register for the exam and please take the exam. See, the exam is for certification. If you're interested in a certificate, if you do well in the course, that is 75% the exam and 25% best three or four assignments. That is the three assignments in which you have the highest marks among the four will be taken for 25% weight, and the exam performance will have a 75%. Both put together, if you are above a certain limit, I think about 50% or so, 40 or 50%, you'll definitely get a certificate. And then you'll get different kinds of certificates, elite, gold. There are some three varieties of certificates with the NPTEL website will take you over. And you'll get one of those certificates. Please do. And Balaganesh asks, actually we use constant for proportional relationship. In depth, how can we understand the proportionality constant? Also in rate expression, what is actually mu, beta, and k? Beta, k. Which rate expression, if you can clarify here which rate expression you're talking about, we can explain that. There are, mu is typically the growth rate. Okay, we'll try to answer the first part of the question. How do you understand the proportionality constant? You know that there is a certain relationship between the variable on the left side and the variable on the right side. The proportionality constant gives you the exact magnitude of that relation. I think that's the best way to understand it if you want it in words. I don't know whether that's the answer that you're looking for. Mathematically, it's one variable over the other variable if the relationship is linear. And yeah, this kind of interpretation can be made only for a linear variation between the variables on the left-hand side of the equation and the right-hand side. Pragati asks, what are bioreactors substance? What materials are bioreactors made of? Would that be the question? Okay, let me try to rephrase this question as what are bioreactors made of? The industrial bioreactors are made of stainless steel. Most of them stainless steel 316, 320 are very standard materials to materials of construction for the bioreactors. These are huge bioreactors of lakh plus liters, very commonly used in the industry. In the lab, for a 1 liter to a 5 liter level, we use glass, special glass, which can withstand higher pressures, temperatures, and so on. They do well because we need a visual access to what is happening inside. We use glass in a lab scale bioreactor. In reasonably large scale lab bioreactors as well as in pilot scale bioreactors, and I think in industrial bioreactors, although the material of construction is steel, there is usually an observation window which is made of tempered glass, which is specially constructed so that it can withstand the high temperatures and pressures that are used during the processing. Sterilization typically goes just above atmospheric pressure and say 121 degrees C and so on. Sometimes they might need to go for higher pressures in the bioreactor themselves. And a light is appropriately placed so that you can observe the goings on inside the bioreactor. That's called an observation window in the bioreactor. I haven't come across any other material except for maybe some high grade plastics for wave bioreactors, which are essentially plastic bags, made of special polymers, transparent polymers, in which mammalian cell culture is carried out. It's a use and throw kind of a thing because of the sterility requirements. They use it only once and then they throw it, and they are suitably instrumented in a modular fashion, such that you can monitor everything in the bioreactor but use it only once. And that way, their validation of products becomes that much easier. They don't have to validate from a sterilization point of view also in the industry, and that's the reason why that is preferred in some industries that use mammalian cell culture. Then Iravati Abhishek says, well teaching, thank you very much. Anupam Kumar says, please discuss assignment numerical questions. Yeah, we will do that that depends on the need. If you ask us specifically which question and so on, may not be here, but we will post the solutions. We have the solutions worked out. We will post that, we'll cut and paste those worked out solutions on the forum. Please ask for specific solutions on the forum of assignments that have already closed. Anupam Kumar again, please discuss assigning numerical questions in upcoming video class. Video classes have been already recorded, so assignments change all the time, and every year there are new questions for the assignments. I think it's most effective to take up assignment solutions as responses to questions on the Ask a Question forum. Any further questions that you may have? I think this is the time that Bharti jumps in and asks a nice question. Where is Bharti? I think we have this is still, we are in assignment. Suresh B, why is tip speed of the agitator related to having the highest shear force in a bioreactor? Okay. Would you want to take a guess and I will go, or would you like me to answer? Why is tip speed of the agitator related to having the highest shear force in a bioreactor? And I think there is we need to understand the question in the context of what Suresh wants. I think he means how why should tip speed be tip speed affect shear in the bioreactor? That would probably be a good way to interpret that question. If we have interpreted it incorrectly, please correct us, Suresh B. Should I answer that? Okay, fine. The okay. Let us see. Um, how do you? I mean, how you can understand shear in a simplistic fashion. We all have heard of shear stress, shear force, shear stress. Let us say that shear force is the force that causes shear stress. And as it goes, stress is nothing but force by unit area. So the force that causes the shear stress is called the shear force. Let us um, consider the terms in this slide for this discussion. What exactly is shear force or shear stress? Let us consider a ball of chapati dough. Did I use that in this video? No, that was in the other video. Okay. Then I might as well take it. Yeah, here I have assumed that they knew what shear was, so I would have done that. And this is how I explain to people who don't have an engineering background, um, especially to people with a biology background and all that. They find it a little easier to understand shear stress this way. Take a ball of chapati dough or puri dough and let us consider placing that ball of dough in between the palms of our hands, placed in opposite direction. Slightly press it. Pressing has no correct interpretation, but let's press it. And let's assume that we move our palms in opposite directions with the ball of dough and caught in between the palms. Right? What will happen to the ball of dough? Sure, you can guess that it is going to get distorted. The reason for distortion is shear stress on the ball of dough, the force acting on the surface of the ball of dough in diametrically opposite directions due to forces in diametrically opposite directions. Due to shear forces, there is a distortion, right? Or a deformation. And excuse me, we are moving our palms in opposite directions. So effectively, there is a velocity in this direction, there is a velocity in this direction. There is a relative velocity between the palms of our hand. That's essentially what it is. And we can generalize the situation to any fluid by saying that if there is a velocity gradient, to understand that, we could have I mean, it's nice. I mean, for us, it's much more comfortable placing our palms this way. We could have placed our palms this way also and moved one faster compared to the other palm, and the same effect would have been noticed. Why? Because there was a relative motion, a relative velocity between the two palms with the ball stuck in. So consider the same situation in a fluid environment. If there are velocity gradients in a fluid environment, in other words, if there is a velocity variation with distance in a fluid environment, and if the cell is caught in between them because of the relative velocity in the opposite ends of the cell is going to experience a shear force and therefore a shear stress. And that shear stress is going to distort the cell or destroy the cell. Um, if your tip speed is going to increase, the velocities are going to increase. The velocity gradients, which is the variation in velocity with distance, that is going to increase. And that is going to cause more and more shear stress on the cells. And this is the reason why tip speed is related to the shear force in the bioreactor. More the tip speed, more shear. Bharti has goaded the students to ask their queries. We need to probably wait, or we need to bring in some in between, what shall I say, means of entertainment. I don't know. Do you sing? I don't sing. I don't sing either. Do you dance? No, that dance is a little difficult. That would be a little difficult. Or we'll wait for a few minutes and then close up. 7. Let us see. Okay, this is a deal. If we get questions over the next couple of minutes, we'll take it up. Otherwise, do you know any good jokes? I can tell you. Ashwati is working with me for a PhD. Would you like to tell them about your study? So I began my research work with bioreactors many years ago. In 1998, so 1988 is when I started my work with bioreactors as a PhD student at Drexel. And my might as well tell the story. Yeah. Hold on. There's one more question. I'll get back to the story now. Why does the power requirement for a bioreactor increase when it is flood or increase with flooding? I think. Okay. When there is flooding, the Suresh B, is it? Okay. The power requirement, if you want to consider the fluid environment in the bioreactor. What is flooding? It's an non-ideal flow situation. If it's a non-ideal flow situation with a chaotic kind of a flow environment, then to maintain that flow, you need more power. So that is the reason why when you have flooding or when you under non-ideal flow situations, there is an increase in power requirement of bioreactors. It is true of any mixed vessel or a well mixed vessel as it is called. In this case, it happens to be a bioreactor. Okay. When we wait for questions, I might as well take you these stories. This was in 1988. I'd always been interested in the biofield. The I when I did my BTech, towards the end of the BTech, I had in fact streamed my electives to take 3 bio-related courses at IIT Madras, and therefore I was oriented towards it. And when I wanted to go for higher studies, I applied in the bio area. Unfortunately, the uh, in those days there was no email, there was no web. We used to get some brochures from the USCFI. We used to go and collect them. We never got them. And then look through whatever they had and so on. Nicely printed brochures. The brochure said that the place I went to, there was somebody who works in the bio area. So I I think that brochure was at least 2 years old. Uh, I got a scholarship to that place for master's studies. So I landed up there and then asked the person whether we could work in something. The person had unfortunately moved out of the bio area some 3 years before that. So I think the brochure was much older than that. It didn't help my purpose at all. So I had to choose something to work on for my master's. So I decided to work in the area of aerosols, as it was called then. Now it is called particulates. It was then called particulates, and now I think it's called particulates. Although the working was in the micron area, micron length scales, not nano length scales. So I did my master's work and then shifted when I had a chance to carry out my doctoral work in the area of biological engineering. It was called biochemical engineering. And I started working with mammalian cells, HP32 hybridoma cells. that produce more. My first project was other questions. So we'll continue. We'll continue for a few minutes. First project was more of a project to pick up skills. There were three other PhD students in the lab, so my advisor asked me to choose between one of the topics and use that project to pick up the skills. And that way, I'll be contributing to the project and I'll be learning the skills and so on. The learning skills part takes only a short while, then automatically go. So, amongst the three that he suggested, the one that caught my attention was the use of milk or colostrum that's um, made immediately after the calf is born. Those two as serum substitutes for hybridoma cultures, because serum costs were about 90% for the immediate loss. Therefore, if we can reduce the cost of serum or find an equal, rather, if we can find an equivalent for serum, that would be good. So we were trying out milk or colostrum. That is my advice. And so that kind of interested me, and I started working on it. And it so happened that it also interested one of my senior students. He said, I'll work with you. I can teach you. And then we went and told her advice. He said, yeah, good work. And first quarter, it was a quarter system metrics. First quarter, I think sometime in November, I started working. I went there in September. So quarter start, first, second week of September. So by November, I had this fixed up, and November third week in the middle of exams, we started work on this. Or in the middle of the quarter, we started work on it. And I picked up my techniques. I was always experiment oriented. Skill pickup was not so difficult. And the project went well. I think I did work on it for about intense work on it. Intense work would be probably 4 in the morning, 11 at night. That kind of thing. Because it was necessary. We had these tea flasks going all the time. For the kind of experiments that we wanted to do, we set up parallel things. I would take measurements once. I think I took all the measurements. Only the quota counter, which was in a different building, for size distribution measurements. I had to take the help of I had to take the help of Octavia, who was currently at the University of Mexico. He's a senior position, technically position. Then we did all that in 4 weeks flat. We had a good amount of data, and a student conference is coming up. MABEC, as it was called, Mid-Atlantic Biochemical Engineers Consortium. That conference was there. It's a consortium. It used to be a consortium of 11 universities, and it was mainly to promote student interactions between students who work in the bio area. And one of these universities, 11 universities, used to host that meeting once in a 2 year at time. And students used to present it with some keynotes by the faculty. So my advisor asked me, would you like to present? And then Dr. Octavia was smart. He said, you be the first author for the presentation, I'll be the first author for the paper. I didn't know anything. I said, that is good. Thought it was good deal. Then the meeting was sometime in February 1st week. Went and presented our data. It was received and wrote it up as a paper for biotechnology bias. Accepted without any reviews. Straight it went, except the thing that came back was that it was accepted. It was a great feeling, and that was my entry into the area. But if you don't know, biotechnology bioengineering is the topmost journal in terms of prestige in the area of biological engineering. It continues to be. I've published about 10 papers there. Still try to publish there as a first choice, if possible. So it's become different now. It's become a lot more difficult. So on. Then we went on. I've worked extensively in the area. Any more questions? How to measure sludge yield of a small anaerobic bioreactor? There are various measures of. I think this question is very specific to the area of environmental engineering. Therefore, I may not know the exact acceptable measures. I'll answer that in some general way. I know what sludge is. The sludge is something that settles down the mass of organisms along with many other solids that settles down. I think the mass measurement is the easiest way of sludge measurement. I'm sure my environmental engineering colleagues have much better sludge measurement techniques, much better knowledge of sludge measurement techniques. I think you should ask somebody who works in the environmental area. Small anaerobic bioreactor. Harold would be able to answer that a lot better. He works in anaerobic bioreactors. Um, if you can raise this question on the forum, I'll ask Harold. Harold will be back from Australia in a couple of days. He's coming back on 24th. I'll get a better answer for you on that question. Yeah, please continue to answer this. I'll continue my stories here. I'm not very sure whether the stories are true. Do we have a choice? Don't know any jokes for this phone. I don't think I can do that. Or can we close? Can we close? There is a question, Varla. In telling stories here. Yeah. Do you need to ask for permission to close? My wish, is it? Oh, my. One. Does anyone know how to prepare rice husk as a feed for USB reactor? Highly specific question. I don't know. That would be the upflow anaerobic sludge blanket bioreactor. I know that UASB stands for that, but I don't know anything more about that. I haven't worked on UASBs myself in a direct fashion. Does anyone know how to prepare rice husk? Yeah, that question is open to all in the area. So if any of the participants know, please feel free to respond to Suresh's question. Also the details keep changing all the time. I may recall something. I mean, I definitely know. I don't know anything about rice husk preparation. I have not come across that. And any of these specific questions, I may recall something from the days that I used to read about things in general, these things in general. But that would have been a long time ago, and things change quite quickly in any area. It may not be very relevant also. I think we will close if there are no further questions. Thank you for participating. Thanks for showing up onto the session. It was nice to share some of these things with you. Wish you all the best. Yes. Oh. Thanks. Thanks. Thank you, sir.